All right, we talked about it yesterday, but I'll say it again. On the quiz, which is Monday, you're going to get one question that says, use complete the square to put this into standard forms, which is like B here, okay? And then you're going to get another question that gives it to you also expanded and asks for vertex, axis symmetry, domain, range, max, min, all those things. But you'll have the option of, do you want to complete the square or do you want to use negative b over 2a? When I do your key, like if it's me taking it, I obviously do complete the square for the one that you need to, but I do negative b over 2a for the other one. So you get to choose, you do what you want to do. But the only reason I would pick complete the square over a negative b over 2a is if there wasn't a number on the front, like then it's not so bad to complete the square. But when you're looking at this example, if I take out the 4, the middle is still a whole number, but as soon as I take out that 4, I have to take the b divided by 2 and square it. Now I'm dealing with fractions that I could avoid if I'll have fractions doing negative b over 2a, but I wouldn't have to do the complete the square. So for 5a, I would do that h is going to be negative b over 2a. So my a is 4, my b is negative 4. So that h is going to be negative 4 over 2 times 4, which is it's positive 1/2. That's the x coordinate of your vertex. Then to find the y coordinate, you got to take that and plug it back in. So everywhere there's an x, I'm plugging in a positive 1/2. So I get 4 times 1/4 minus, this goes in twice, 2 plus 21. These cancel, 1 minus 2 plus 21, negative 1 plus 21, which is 20. So my vertex is 1/2 and 20. Tell me what else that tells you about your parabola. What else you know as soon as you know your vertex? Your axis symmetry is what? Nope. Just x equals 1/2, okay? Does this parabola open up or down? Up, which means you have a min or max? Min, and what's that minimum value? 20, good. You also know first of all, it's a parabola. The second you know it's a parabola, you know domain is all real numbers. And because it's a parabola that opens upward, it starts at your k and points up. So your range would be 20 to positive infinity. The other thing you can really quickly find if it's an expanded form is your y-intercept, because this would be 0 and this would be 0, so the y-intercept would be 0, 21. So all that stuff can be easily figured out, okay, by just knowing your vertex and which direction it faces. If I needed to find the zeros here, I will tell you right now the one on your quiz is going to be factorable, okay? You'll be able to factor it, or you could use the quadratic if you're not a huge fan of factoring or you're worried about it, okay? You could use the quadratic. But I would then set it equal to 0 and solve it. Questions? All right, B says put the function into standard form. So now I'm going to take my 4x squared minus 4x plus 21. I'm going to group the first two terms together. I'm going to take out that 4. So 4 comes off of both the x squared and the x. Then to find that term I'm missing on the inside, I'm going to take the b, which is negative 1, divide it by 2, and then square it, and I get 1/4. I add the 1/4 inside the parentheses, and I'm going to subtract it outside the parentheses because I'm balancing out the right-hand side of this equation. Before I can subtract it, however, I've got to multiply it by what I took out, so I'm multiplying by 4. The 4 and the denominator cancel out, and this ends up just being a -1. So then the whole reason I did that process was to put it into a perfect square trinomials, which means I can now factor it using my shortcut. Square root the first term, square root the last term. So the square root of this is the same thing as what I got before I squared it. So after you divide by 2, but before you square it. But it's also just 1/2. Take the sign from the middle, put it in parentheses and square it, and then positive 21 minus 1, positive 20. Which is consistent with my vertex being 1/2 and 20. And it's consistent with it opening upward, and it's consistent with it having a domain of negative infinity, positive infinity, and a range of 20 to 0. And the y-intercept is way easier to find from expanded form. Questions? Okay, so today we're going to do the first part of 2-2, which is polynomial and rational functions. We're going to do part 1. The notes I actually divided. So we're doing all of the notes that you opened today, and then there's a part 2 note that we'll do tomorrow, okay? Everything by the end of today, everything that's on that will be on your quiz. The part 2 is not on your quiz. It will be on your test, but it's not on your quiz, okay? Which, again, quiz Monday. So today we're talking about polynomials beyond an x squared. So it could be x squared, but it also could be an x to the third or an x to the fourth or an x to the fifth. These are all continuous functions or continuous graphs, which means 1, degree of 2 or higher. 2, they are smooth and continuous. So these are not going to be piecewise functions, okay? They only have rounded curves with no sharp corners. There's no breaks. So it's like your roller coaster shape polynomials, okay? Something like that. It could go up and down and up and down. But it has to be smooth and continuous. You can draw it all with one stroke. And there's no sharp curves. So everywhere is going to be rounded. So the ones on the left here are what polynomials could look like. The ones on the right would not be polynomials. They can't have a stop and start. It can't break up like a piecewise function, and it can't have a sharp corner. The first thing we're going to graph is a monomial. Do you know what a monomial is? What's mono mean? 1. So this has one term. This is either going to be like f of x equals x to the 4th, or x to the 3rd, or x to the 6th. It could be plus or minus a number, okay? There could be a number on the front. There could be a number inside the parentheses, but there is, not inside the parentheses, just that. But there is only one x on these, okay? And the rule is if that n, which is your highest exponent, is even, then it resembles the graph of x squared, meaning the edges are going to point up if it's positive, and it's going to kind of flatten out in the middle, or it's going to point down. If the highest exponent is odd, then it's going to resemble the graph of x to the 3rd, meaning the right-hand side is going to point up and the left-hand side is going to fall down. And if it's negative, the left-hand side is going to point up and the right-hand side is going to point down. Now, the greater the value of n, so the higher the exponent, the flatter the graph is near the origin. The flatter this part of my graph is, or this part of my graph is. And you don't have to worry about that too much because these are going to be approximations of these graphs, but just know if you were comparing to, if I was comparing an x to the 2nd to an x to the 4th, that x to the 4th would have a flatter curve. And we'll talk about why in a second. All right, so these, again, approximations. Sketch the graph. So A says x to the 7th plus 1. The highest exponent is, it's a monomial, first of all, because there's only one, x being raised to a power. X to the 7th. That tells you it's odd, yes? It's positive. So where are my arrows pointing? The left side's pointing where? Down, right? Like an x cubed. The right side's pointing up. So this is going to take on the shape of an x cubed. And the plus 1 does what? Shifts it up 1. So I literally shift it up 1. And instead of making it like this, I just flatten out in between the 0 and the 1. So let's think about why it flattens it out. If I take a number between 0 and 1, for example, a fraction or decimal, right? Let's say I take 1/2. If I square 1/2, I get what? 1/4. If I cube 1/2, I get 1/8. Good. If I raise 1/2 to the 4th power, 1/16. So what's happening if I compare 1/2, 1/4, 1/8, 1/16? What's happening? They're getting smaller, yes? If I take a number between 0 and 1 and I raise it to a higher power, the higher the power, the smaller the number. Does that make sense? So that's why it flattens out around here. We don't need to be perfect. We just need to know that if there was an x to the third and there was an x to the seventh, that in between the 0 to 1 to 0 to negative 1 would be flatter on the x to the seventh than it would on an x to the third. All right, go to B. Now, what type of exponent do you have? It's 4, which would be what? Even or odd? Even, so it's going to follow the characteristics of a parabola. It's positive, so it's going to open up. And the minus 1 on the inside does what? To the right one. So I shift it to the right one, and I just kind of flatten out what happens in between the vertex and the next coordinate point. Again, these are just approximations. We're going to get a little bit more specific in a second. But a monomial, you approximate. You with me so far? Okay. All right, so let's talk about end behavior. The end behavior literally means what's happening at the ends of your graph. What's happening on the left side and the right side of your graph. And we determine end behavior by something called the leading coefficient test. So sometimes directions will say, use the leading coefficient test to determine the end behavior of your function. I simplify this on the next slide. It's a little bit easier to read, but just so that you know, if the highest exponent is odd, and the leading coefficient, which is the number on the front of the highest exponent, is greater than 0, which means it's positive, then my parabola points up on the right, so it rises right, and it points down on the left, it falls left. If my highest exponent is odd, and the number on the front of it, leading coefficient, is less than 0, which means it's negative, now it reverses it. It rises left, and it falls right. If your highest exponent is even, then they both have the same behavior. If it's even and the leading coefficient is positive, then they both point up. So it rises left and it rises right. If it is even and the leading coefficient is less than 0 or negative, then they both point down. So it falls left and it falls right. So we don't know yet what's happening in between those arrows. The end behavior literally just describes the outsides of your graph, the left and the right hand side. So here's all that in words. The odd degree polynomial has opposite behavior at each end. If A is positive, then it falls left and rises right. If A is negative, then it rises left and falls right. So odd points in different directions, like an x cubed. An even degree polynomial has the same behavior. If A is positive, then both ends point up. If A is negative, both ends point down. So sometimes it will literally just ask you to describe the end behavior, and sometimes you'll get a multiple choice question with different graphs, and it will say which of the following could be the graph of this polynomial. And from your graph, you'll either have both ends pointing up, both ends pointing down, left pointing down, right pointing up, or left pointing up and right pointing down. And based on the end behavior, you could figure out which graph it could be. All right, so example 2 says use the leading coefficient test to determine the end behavior of the graph of f of x equals negative 3x to the third minus 4x plus 7. First of all, don't assume that the first one's always going to be the highest exponent. This can be in any order, okay? And that's usually how they'll try to trick you. This time it is. Highest exponent is 3, which is odd, which means they're going to be different. So then I go to the leading coefficient. What's true about that negative 3 at the front? It's negative, which means what happens on the left? Up, left, right, falls right, which means rises left, falls right. Good so far? All right, then we're gonna find the zeros of the function. So we're kind of gonna go in this order when we put it all together. In a polynomial function, the values of x for which f of x equals 0 are called the zeros of the function. We've talked about this before. They are also referred to as the roots or the solutions of the equation. Each real root, because we're eventually going to get into i's, each real root of a polynomial equation appears as an x-intercept of the graph of the polynomial function. So every solution to your equation is going to be a point that's plotted on your x-axis. All right, so example 3 says find all the zeros of x to the third plus 2x squared minus 4x minus 8 equals 0. Now initially this could also just say equals f of x, okay? And you would need to know that when we're finding zeros, we change that f of x to the 0. There's all the different types of factoring in this section. You could get difference of two squares. You can get greatest common factor. You could get perfect square trinomial. You could get the a not being 1. You could get a 4 one where we're factoring by grouping. They could all get mixed in, okay? So when there's 4 terms, we factor by grouping. From the first set of parentheses, I can take out an x squared, and I get x plus 2. And from the second parentheses, I could take out a negative 4 or a positive 4. I need the signs to change. So I know I'm going to take out a negative 4, x plus 2. And now x plus 2 comes out. And I would group together what's left, x squared minus 4. Is that factored completely? No. X squared plus 4 is the difference of two squares. That becomes x plus 2 and x minus 2. So the zeros of my function, when I set these all equal to 0 and solve, I'd get negative 2, I get negative 2 again, and I get positive 2. When I list the zeros, I literally just list those values. In a minute, we're going to talk about why it's important that that negative 2 happens twice. But when you are listing them, you literally just list them, not in coordinate point form. You could write x equals negative 2 and 2, but you cannot don't put them in coordinate point form. All right, so let's talk about multiplicity. Multiplicity of intercepts, okay? If a root occurs more than once, then the multiplicity is the number of times a root occurs. If it occurs an even amount of times, then the graph just hits the x-axis and turns around at that point. If it occurs an odd amount of times, then the graph crosses through the x-axis at that point. And you'll see these two different ways. Like it could either be like we just did where it's not factored and you have to factor it, but you could also see it already factored for you. So if it's already factored and it's squared, that means I would set it equal to 0. I get an answer that's 1, right? One of my zeros is 1. But it occurs twice, so there's an even multiplicity there. I just literally put a little 2 in a circlet to remind myself. Then I'd have negative 3, and then I'd have 4. So the graph of this function is going to bounce at positive 1, but cross through at negative 3 and positive 4. So if I was looking for a graph, 1, 2, 3, 1, 1, 2, 3, 4. Then it could, first of all, the highest exponent here would be x to the 4th, because it's x squared times x times x. It'd be a positive x to the 4th. So my end behavior, both are going to point up. At negative 3, it's going to cross through. I don't know how low it's going to go yet. We'll talk about strategies on that in a second. Then it's going to come back up. It's going to hit 1 and bounce off of it. And then it's got to come back up and cross through 4. And again, we'll talk about like figure out how low to go on that graph, how like all those things. But I know from the multiplicity that it would cross through at -3, it would cross through at +4, but it bounces at +1. We good so far? All right. Turning points is how many times it physically changes directions, okay? It happens every time there's a max or a min. So your turning points, 1, 2, 3, there are 4 turning points here because it changes from increasing to decreasing, then decreasing to increasing, then increasing to decreasing, then decreasing to increasing. So if I count up 1, 2, 3, 4, there are 4 turning points here. If I count up my max and my mins. The rule is that if a function is a polynomial function of a degree n, whatever, that's your highest exponent again. Highest exponent. Then the graph has at most n minus 1 turning points. So if my exponent, the highest exponent is 5, the most amount of turning points it could have is 4. Now, why does it say most? Because it could have less than 4, because some of my zeros could be complex and then you won't see them on your graph. That's the most amount of turning points it could have. But it can have less. All right, so example 4 says, find the zeros, determine the multiplicity, determine the maximum number of turning points, and use a graphing utility to verify. So this is the same question we already factored, right? We factored it. We took out the x squared, x plus 2, -4, x plus 2. We got x plus 2, and then x plus 2, and x minus 2. And our zeros were -2. Now we know there's a multiplicity of 2. So that's important. And +2. So what's going to happen to my graph at -2? It's going to bounce. What's going to happen at +2? It's going to cross through. What's the maximum amount of turning points? 1 less than your highest exponent. What's your highest exponent? 3. So what's the max amount of turning points? 2. Good. All right. If you haven't used Desmos, I would strongly recommend you try it. I'm going to pull it in, okay, so that we can see it working. All right. So Desmos is like an online tool, but it's also an app if you want to get it, okay? So I'm going to graph this. I would do y equals x to the third plus 2x squared minus 4x minus 8. So what's helpful, I would say, about Desmos that your graphing utility is a little bit harder to do is I can literally pinch and zoom this out. So if I needed to get further out, like on that example that we did yesterday, right, the parabola that we did yesterday, if you needed to zoom further out, I could literally just pinch and zoom it. But this graph is consistent with what we thought, okay? It bounces off of -2 and it crosses through 2. If I had looked at the end behavior, my highest exponent was odd and it was positive, which means it also falls left and rises right. Okay, so we've done this before, but this is your refresher on how you could find your zeros on your TI 84, 83, whatever it is, okay? One way you can find your zeros is by looking at your table, okay? The catch here is that it will only get it if it's a whole number. So only if you, which is not always going to happen, only if your x values are whole numbers will you be able to see it from your chart. But what you are looking at in that table is where your y values are 0. The other way you get it, and we have done this already, is use the 0 tool on your calculate. So second trace, 0, left of the 0, right of the 0, enter, and then do it again for every time it crosses. Okay. This is something that would be expected for you to do on your test again. All right, so we're going to put all the things we talked about today together to be able to graph these functions by hand. The very first thing you're going to do is use a leading coefficient to determine your end behavior. So I'm going to find my highest exponent. Is it even, odd? Is it positive, negative? Now I'm going to know my end behavior. Then I go to the x-intercepts. X-intercepts, meaning your zeros, set it equal to 0, solve it, and pay attention to your multiplicity. So all of this is your multiplicity, okay? No, sorry, that's not. That's your flattening. I don't even pay attention to that because what you're going to do the rest of the time is going to work. So you want to find your intercepts and you want to check the multiplicity. Then you can find your y-intercept because that's going to help you have another point to figure out how high or how low to go on that y-axis, okay? And then I would say the other things on here we use to check our graph. You don't have to do those things to graph them. But one, if it has y-axis symmetry, so if it's an x to the second and there's no other x, if it's x to the second or x and x to the fourth and there's no odd exponent, then I know it's symmetric to the y-axis. And the benefit of knowing it's symmetric is that I could plot one point on the right and know it's going to reflect onto the left. If it's got origin symmetry, meaning like all your x values are raised to an odd power and there's no constant, then I would know everything happening on the right-hand side of my graph gets flipped. The coordinate points, the negatives of both those coordinate points would go to the right. So it eliminates the need for extra points. And then for the max turning points, it would just be your check. If you said the max turning points was 2, but your graph turns 3 times, now you know something's wrong. All right, we're going to put it all together. So it says graph x to the fourth minus 4x squared using what we've learned in this section. So first thing I'm going to do is make sure it's in order of highest exponent down to none, and it is. And then I'm going to find my end behavior. So what's true about the highest exponent, even or odd? Even. Positive or negative? Positive. What's that tell you about your end behavior? Both up. Okay? It's going to rise left and rise right. Then I'm going to find my zeros. So 0 equals x to the fourth minus 4x squared. How do I factor this? Good. X squared times x squared minus 4. Is that factored completely? No, there's a difference of 2 squares there, x plus 2 and x minus 2. Now I solve them. So what are my zeros? Negative 2, positive 2, and 0. What's special about 0? There are 2 of them, which means it's going to bounce at 0. If I didn't already find my y-intercept, I'd find it. This time, because we have 0, 0, that's also your y-intercept. But if we didn't catch it, it would be 0 to the fourth minus 4 times 0 squared. Y is 0. So y-intercept is 0, 0. Now I'm going to put all that stuff on my graph. I know this is really hard to see, the line. Okay, so I've got a 0 at negative 2. I've got a 0 at 0, and I've got a 0 at positive 2. And what happens at the ends? Both go up. Now what happens at negative 2? Does it bounce or cross through? At negative 2 it crosses through. I'm going to come down. I don't know how low yet. But then I got to come back up because it's got to hit 0. What happens at 0? Bounces. So it bounces at 0. It's going to come back down. And then I got to come back up at some point because it has to cross through 2. So in between every set of coordinate points on your x-axis, so every 0, you need a point plotted, which means I'm going to plug in negative 1 or positive 1, okay? If I understand my symmetry, if I plug a negative x in here and a negative x in here, what's going to happen? What happens if I have a negative x and I raise it to an even power? It goes positive, which means this has y-axis symmetry. And what that does is eliminates my need to plug in both -1 and +1, because if I just plug in one of those, I reflect it. So I'm going to plug in the easy one. I'm going to plug in +1. And when I plug in 1, 1 to the 4th minus 4 times 1 squared, I get 1 minus 4, which is -3. And now I know at 1 it's going to be at -3, and because of my symmetry, at -1 it's also going to be at -3. And now I know I can bring this down, bounce it back up, bring it back down, and bounce it back up. So if you don't remember your symmetry rules, then you're plugging in both points. If you remember your symmetry rules, it's going to help you to eliminate some work. Yeah.
On the calculator, it drops lower than that.
Well, because we have an estimate, right? We don't know how low it goes in between. It could go down and come back up here. It could go down and come back up here. As long as it's passing through those points, it's okay. These parts are not, I don't expect to be perfect, okay? But usually the rule is like, and also like if there's a point here and here, but then there's a point that's more spread out, the more spread out your zeros, the lower it's going to go or the higher it's going to go. So we're doing an approximation in between, okay? If you had your graphing utility, obviously I'd expect it to be more accurate, but you're not going to have a graphing utility on a question like this, so you're just going to estimate what's happening in between there. All right, last one, done for the day. So we're doing, again, putting it all together. So what's true about the end behavior? No? It's odd, highest exponent's odd, and positive or negative? Positive. What's that mean? Falls left, rises right. Then what are we going to do? Find the zeros. So 0 equals x to the 3rd minus 9x squared. How do I solve that? Good. Take out the x squared and I get x minus 9. Now we split and solve. And I get x equals 0. But what's special about it? Multiplicity of 2, so it's going to bounce there. And x equals 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Falls left, rises right. Y-intercept already found, 0, 0. But a lot of times that will help you out too. Alec, head up. Now I know it bounces at 0. It's going to come down. It's going to go back up again. But I don't know how far it goes. Again, the wider the space, the more it's going to dip. Okay? So we're going to pick a point. If you're going from 0 to 9, you want to pick a point more in the middle of it. I don't want you to plug in 4.5, but you can plug in 4 or you can plug in 5. Okay? So I'm going to plug in 4. 4 to the 3rd minus 9 times 4 squared is 64. Minus 9 times 16, which is 144. Yeah. And 64 minus 144. Right? Did I do it right? Yes, 144. Okay. 144 minus 64. Wow, I did it wrong. Do it the other way. Okay. Is negative 80. Do I want you to go all the way down to negative 80 and plot these points? No. But what you do need to do is just drop it as low as you can go, and then plot and label your point for negative 80. So again, you're going to find that in the solving, there's all the different types of factoring, okay? If you run into something you don't remember or you know you need practice, that's one of those prereq skills that's on that module, okay? It's actually on last module, but it is definitely something that does not go away. Questions on anything we talked about today? So this is where your quiz content ends. Tomorrow we're going to learn second part of 2-2, which will be on your test, but not on your quiz. But this is where your quiz content ends. And your homework is split. So 2-2 part 1, which is tonight, is due tomorrow. And then I separated off 2-2.